that we found so far, we've either been able to use our ratios or we were able to use our unit circle. Stuff we're going to be looking at today is not that friendly. It's going to be long decimal stuff and stuff that's not on your unit circle. So this will be when you would go to your calculator. So this first one that we have here says to find the sine of 49 degrees and 12 minutes. Now a little bit about our calculators. First off, they default to radian mode. So anytime you're doing this type of trig stuff in your calculator, you need to hit mode and go down to about the third one and make sure it's in degrees. Okay, you'll get some wrong answers if you're not in degree mode. Alright, but the dilemma here with this first one that we're looking at is that that's not in degree mode. It's got a 49 degrees, yes, but that 12 minutes is not degree mode. So this goes back to the last unit. You got to be able to convert that to degrees. So you can just type in 49 degrees and 12 minutes and hit enter. What do you got when you do 49 degrees and 12 minutes? 49 point what?
2.
49.2. Everybody able to do that? That's old stuff. What you got, Zing Zing? Okay, you're ahead of us. All we did first was just converted that. And that may end up being the same answer, Zane, so yeah, it is. Okay, I'll talk about that in just a second because you just found something I didn't know. Alright, so now I'm going to hit, well, I haven't finished yet. I got 49 degrees and 12 minutes is the same as 49.2. Well, you're ahead of me. I'm not there yet. Then I'm going to hit sine of 49.2, and Mason, tell me 4 decimals that you got on that.
Negative 0.87.
Okay, that's not right.
Nope.
This no.
First thing I said was make sure you're in degree mode. So we're going to say about 0.757 would look pretty good. Does that look good? About 0.757. Now I did not know this. Nobody in first period pointed it out. It's what Zane and Mason were doing, and Mason's will work when he gets it in the right mode. Zane just typed it in like it was, and it worked for him, and he got the right answer. So you didn't even have to do that conversion that I thought you did. So good job on that. Mason, you'll get it now that you've got it in degrees. Did you? 0.7. Yes. Yes, that's right there. You got it, so. Yes. Did it get it for you? All right. Okay. Now, this one's a little bit different. I got the secant of 97.977 degrees. All right, already in degree mode, 97.977. What do you think the dilemma with this one is?
It's not a cosine.
Good, we don't got a button that says secant like Zane's saying. That's exactly right. So we got to know which one secant is the reciprocal of. Any guesses on which one secant is the
Cosine.
cosine? Very good. So I can say that this is the same as cosine, and to take the reciprocal of that, how do you know how to take the reciprocal of something ugly like that?
1 over cosine.
Very good. Just put it all underneath 1. So that's what you're computing in your calculator now. Now say since they gave us 3 decimals, let's put our answer to at least 3 decimals. Anybody got one yet?
Yep.
Oh, you got it. Yours is right, negative 7.206, maybe. Hit mode, make sure you, yeah, you're good. Go back and look at it again. I don't know what was. What's that? What's wrong with that? Let me see if just dividing makes it like it should. y'all's calculators are possessed. No, that's what theirs is saying too, and I don't know why. The correct answer is negative 7.21 about, but some of these calculators are messing. They're growing crazy. Let me see how you had, yeah. I didn't think of telling them all that. 97.977. Yeah, that's right. Alright, and this is, y'all need to this is my fault. I didn't word it all to you correctly. So make sure y'all see how we're going to write this. Secant is the reciprocal of cosine, right? And we got that. But this whole thing here is what the secant is looking at. So we need to divide that whole thing by 1. So what you'll type in the calculator needs to be better written how I wrote it. I'm going to do 1 divided by that whole thing. And I didn't really get my cosine up there down on the bottom like I should have. Should have been written more like that. That's my bad for not getting you there on the right buttons. Did you get it right that time? Good, good. And that's my bad, but that's why we're practicing it so we know get it. Alright, so this one says, as soon as the page turns, let's do a couple more of these and we'll move to the next time. 1 over the cotangent of 51.4283 degrees.
Isn't that just tangent?
Remember, that's cotangent, like Kaylee reminded us, is the reciprocal of tangent. So this is the same as just doing the tangent of 51.4283. This time they gave us 4 decimal places, so we need to try to give at least 4. That's no written in stone law kind of thing, but that's just good math on that. Whatever you're given, you need to do your answer that same way. So I got 1 point what?
2539.
2539 about. Okay, nothing to it. 1 more of those, and then we'll shift gears. I've got the sine of negative 246. This one's really one of the easiest ones that we've got, but people panic when they see that negative in there, but you can still just do that. Just type it in your calculator like it is, and it will work fine for you on that. This one we don't have a decimal place to guide us, so I'm just going to say hundreds will be fine. So when you get that, round me to the nearest hundreds. About 0.91. Are you all right on that? Okay. So a major note of importance was what I didn't tell you at first. When you do the reciprocal, even the function goes on the bottom. So it'll be 1 divided by whatever your reciprocal identity is. Okay, so next thing, shifting gears a little bit now. This one says sine of theta is approximately 0.9677091705. Maybe several digits there. That's a 7 that's all jacked up there. What's different between how this is written and how the last problem was written?
How do you place any sine of theta?
Before you figure it out, tell me what's different between this problem and the last problem.
Theta.
Very good. So what we don't know this time is the angle. On the previous problems, we knew the angle in degrees, and this time we don't. This is when, and everybody always wants to use it, this is when you get to use your inverse functions. Because we're trying to solve for the angle, we're going the opposite direction, so we're going to use the opposite. We're going to use the inverse. So we'll do the inverse sine, which is just second sine, of that. And that will be your angle theta in degrees. So theta will be approximately, what'd you get?
75.414.
Very good. Thank goodness we don't have to write all of those digits out. I don't think it went that far and had that many. You can't. It's just like an X, so there's not a theta button on it. All right. So another one of those. I've got secant of theta is equal to 1.0545829. Okay, so again, we don't have a secant inverse button because we don't have a secant button. So we got to remember, we had it earlier, we got to remember what is secant the reciprocal of? Cosine. So we're going to be dealing with the inverse cosine. So we could say that cosine of theta is equal to, right? So then, let me get Chase changed over here. There we go. Then, when you go to your calculator, you got a button that you got now. You got the inverse cosine. So you're doing just like we did before. Everybody got an answer for me?
18.51.
18.51 degrees. Is that good? Did you get that, Zane? Still working on it? Did you get it, Kirsten? I'm not ever sure about how exactly to tell you to type it in, so I'm going to make sure.
Yeah, 18.1.
You got to do the inverse.
Oh, -1.
And I think, go ahead and try it there and see what happens. I think, yeah, you got, it's going to be, let's see, you're going to type it like this. Don't put the cosine on bottom this time. I got it all scribbled up down there when I typed it. Hold on that. Yeah, that's it. No, it won't be completely different, but it might be right. It might be a decimal or two off from the rounding. And like it's like everything else. The more times you round, the less accurate your answer gets, and that won't be a big deal unless like the test has 18.51 and 18.52. You know, then it would get into, oh, that's pretty close. Maybe I need to put all those digits in. You know. All right. Last type of question we got is where we have a formula to use that actually deals with this stuff. Bless you.
Thank you.
So my formula here says force is equal to weight times the sine of angle theta. What this is, read you the background that goes with this formula. It says when an automobile travels uphill or downhill on a highway, it experiences a force due to gravity. This force F in pounds is called grade resistance and is modeled by that equation where theta is the grade and W is the weight of the automobile. If the automobile is moving uphill, theta is greater than 0, that means positive. If the automobile is going downhill, theta is less than 0, which means negative. Okay? So we got 3 questions we're going to use that formula for. Question A, calculate F to the nearest 10 pounds for a 2,500 pound car traveling an uphill grade with an angle of 2.5 degrees. So I said a 2,500 pound car, so there's your W, times sine, and I said angle theta, we're going uphill at 2.5 degrees. It told us to round that to the nearest 10 pounds, so it wants like whatever 10, 20, 30, 40, it wants a 0 on the end. So type that in your calculator and round it to the nearest 10 pound. Tell me what you got.
$110.
110 pounds. Now, what that means is that poundage of car, and I don't think that's a very heavy car, I'm not sure. 2,500 pound car going uphill at a 2.5 degree angle. It's like the force is pushing on it, adding another 110 pounds to it.
I got just 109.
It said round it to the nearest 10 pounds. So,
So it would have.
yeah. So if it said round to the nearest 10, it'll have to end in a 0 because I've got 10, 20, 30, 40.
Okay.
So if it had been 10,
I was thinking you would round from the 10th place to 0, but that's just
well,
yeah.
You're good now?
Yeah. You said 10, so I was thinking. Just
I got you.
Yeah.
How are you today, Grace?
I'm good.
All right, let's do another one of those. This time, calculate F to the nearest 10 pounds, so same rounding again, for a 5,000 pound truck. So we'll start off here with 5,000 pounds times the sine of going downhill with an angle theta of negative 6.1. Okay, so this is a heavy truck going downhill, so it's going to have like a pretty heavy weight on the back pushing it downhill faster. Should be a negative because we're going downhill, so don't panic when your answer is negative.
Or rounding to the 10s.
Uh-huh. What you got?
Negative 530.
Not a kid. Negative 530 pounds. If y'all ever been driving on the interstate, well, y'all probably go way faster than me, so it's probably not a problem. But you've caught up with a big truck, so you want to start passing it, but then all of a sudden you go downhill, so that speeds that truck up and it takes off and you can't pass it. So you get mad and you get behind it again, and then all of a sudden here it comes uphill, which slows the truck down, and it's like back and forth all the time. Gets on my nerves. Guess I'm the only one that's ever happened to. You are probably going 95, so it doesn't matter. Woo! All right, last one of those here. But this one's kind of a two-parter, so I'll get us a new page on it. It's a funny one when you think about it. F equals W times the sine of theta. All right, I want us to compare here with a 0 degree angle and a 90 degree angle. And we don't even know the weight of the car. So we just want to think about what's going to happen with a 0 degree angle and then compare that to what's going to happen with a 90 degree angle. Well, look at your unit circle. Okay, what's the sine of 0 degrees on your unit circle? Sine's the second one. Sine's the second of the ordered pair. What's the sine of 0 degrees? 0, right? So this sine of 0 degrees is equal to 0. So that means if an angle is 0 degrees, our force would be 0 pounds. That should be common sense to you because an angle of 0 degrees is flat as a pancake. You're just driving through Kansas. There aren't any hills, so you don't have anything, a weight slowing you down, or you don't have a weight speeding you up. Now what about 90 degrees? What's the sine of 90 degrees? 1. So if we had a sine of, I wrote sine like that, that's funny. If we had a sine of 90 degrees, that's equal to 1. So if you have a weight...
Attention teachers, anyone who wants to donate blood at this time, please report to the new gym.
So if you have any weight times 1, it's the same. So that's like, say your car was that 5,000 pound truck we talked about. Now the force is 5,000 pounds also. If you were that little 2,500 pound car we talked about, now the force is 2,500 pounds also. Why? I mean, that's a lot. That's doubling whatever your car already weighs. Now you got that much force on it, so that's doubling. Why is that? What's a 90 degree angle look like if you're driving on it?
A little more straight.
It's right. You're either going straight uphill or straight downhill, right? 90 degrees positive would be going straight uphill. So however much you weigh, then you got to double that to get things straight on up that hill. So does that make sense that a 0 and a 90 would be like that? And pretty cool to think about that way. I always get confused, like when you're driving to Branson and stuff, you see those signs on the side of the highway. It says warning steep grade 10%, and you're thinking 10%. That's not very steep if you compare it to 100. But when you start doing all this, 10% angle would add a lot of weight on a car. So, all right. told you short and sweet and not much to it. Next lesson is right triangles. Those are the types where you have, and you've seen these, we've done them a lot, where you got a flagpole. You can draw a triangle off your flagpole, a tree, draw a triangle off a tree, the ladder leaning on the side of the house, draw that triangle off of all that. So that's the next lesson we got. I don't know. I guess that'll probably be, well, I don't know for sure when that'll be. I know we'll be in the Powder Puff game, and then I heard yearbook things coming up too. So just be ready whenever we're here. We'll have a lesson and get stuff knocked out as we need to. Okay. I heard it's Wednesday, but I didn't hear what time.